All right, let's dive into a tool that's pretty much the foundation of modern monitoring, Prometheus. We're going to break down how it collects data from even the wildest, most chaotic systems, and more importantly, how you can start asking it questions to figure out what's really going on under the hood.
So, picture this. You're running a modern app, right? You've got containers popping up and disappearing, dozens of microservices all talking to each other. It's organized chaos. Now, how in the world do you keep an eye on all of those moving parts at the same time? Well, that question right there, that's the exact problem Prometheus was designed to solve.
So yeah, let's start with what Prometheus actually does. It's all about bringing a sense of clarity, a sense of order to the chaos of these big, modern, distributed systems.
At its heart, Prometheus is an open-source monitoring and alerting toolkit. Fun fact, it was actually born at SoundCloud way back when they were dealing with their own microservices explosion. Now it's a huge project, part of the same foundation as Kubernetes, and it is built for one thing above all else, reliability. When everything's on fire, this is the tool you count on to tell you exactly where the smoke is coming from.
Okay, so how does it actually get the data? This is where Prometheus makes a really interesting and kind of unique architectural choice. Let's talk about its pull model and these things called exporters.
So a lot of systems work by having your applications constantly pushing data to a central server. Prometheus flips that script. The Prometheus server actively reaches out and pulls, or scrapes, the metrics from your services. This is a huge deal because it means the server is in control. It can get overwhelmed by a sudden flood of data, and if it can't reach a service for a scrape, well, it knows immediately that that service is down.
And this little diagram shows you just how beautifully simple it is. The Prometheus server just makes a standard HTTP GET request to an endpoint on your app, which is usually just called /metrics. Your app then just hands over all its current metrics in a simple text format. That's it. It's clean, it's robust, it just works.
But you're probably thinking, okay, but what about stuff I can't just add a /metrics endpoint to, like my database or the Linux server itself? And that's where exporters come in. Think of an exporter as a helpful little translator. It's a tiny service that sits right next to your database or whatever, pulls the metrics out in that system's native language, and then translates them into the Prometheus format for scraping.
And the ecosystem here is just massive. I mean, seriously, there are official and community-built exporters for pretty much anything you can imagine. Databases, messaging systems, your web proxies. The node exporter will even give you deep stats on your hardware, like CPU and memory. This huge ecosystem is what makes Prometheus so incredibly flexible.
Okay, so we know how Prometheus gets data. But what does that data actually look like? Let's get into the basic metric types, which are kind of like the fundamental language of Prometheus.
First up, you've got the counter. The easiest way to think about this is like the odometer in your car. It's a number that only ever goes up. It never goes down. The only time it goes back to zero is if the service restarts. It's perfect for counting things that just add up over time, like the total number of website visits or total errors logged.
But here's the secret. The total number itself isn't usually that interesting. The real magic of a counter is when you calculate its rate of change. You don't just care that you've served 1 billion requests, you want to know how many requests you're serving per second, right now. And that's exactly what you use counters for.
Next, we have the gauge. If the counter is the odometer, the gauge is your speedometer. It's a single value that can go up and down. It's a snapshot of a value at a specific moment in time. Think things like current memory usage, the number of jobs in a queue, or the temperature of your CPU. It's a direct measurement of what is it right now.
All right, now we get a little more advanced with histograms. These are amazing for measuring distributions, things like how long your API requests are taking. A histogram doesn't just give you one number, it gives you a few key pieces of data. A total count of how many requests you measured, a sum of all their durations, and a series of buckets that show how many requests were faster than, say, 100 milliseconds, 200 milliseconds, and so on.
Now this brings up a really important point. Histograms versus summaries. And here's the key takeaway, the big difference. Aggregation. Because a histogram gives you those raw bucket counts, you can add them up from all your different servers to get an accurate, cluster-wide view of performance. You just can't do that with summaries. So for distributed systems, histograms are almost always the right call.
All right, now we're going to talk about the feature that honestly makes Prometheus, well, Prometheus. And that is its incredibly powerful dimensional data model, which is all about labels.
This is like rule number 1 in the Prometheus handbook.
A time series isn't just defined by its name. It's defined by its name plus a unique combination of these key value pairs called labels. Think of labels as adding context or dimensions to your data.
And this example shows it perfectly. Look, we have the same metric name here, HTTP requests total. But because the code label is different, one is 200 for success, the other is 500 for an error, these are two completely separate, unique time series. One is tracking your successful GET requests, the other is tracking your errors. You can slice and dice your data by literally any dimension you can think of. It's so powerful. So, we've collected the data, we've structured it with metric types and these awesome labels, and now for the fun part. How do we actually ask it questions? For that, we use Prometheus's own query language, PromQL. Let's start with a really common practical question an engineer would ask. We've got our request counter, and we want to know how fast is it going up right now for our main API server.
And here is the PromQL to answer that. We use the rate function, we tell it to look at our HTTP requests total metric, then, and this is key, we filter it down with a label selector, job equals API server, and tell it to look over the last 5 minutes of data. The beautiful part is that rate is smart enough to handle those counter resets we talked about, giving you a nice clean request per second value.
Okay, one more. That's cool for one job, but what if we want to see the request rate for each of our jobs all on the same graph?
For this, we use an aggregation operator. We just wrap our previous rate query in a sum, but we add this little clause, by job. This is us telling Prometheus, hey, I want you to sum everything up, but I want you to keep the job label so I can see a separate result for each one. This is that dimensional model in action, and it's what makes querying so flexible. So, we've collected metrics, we've labeled them, we've queried them. There's really only one crucial piece of the puzzle left to make all this information truly useful.
You have this incredibly powerful source of data now. So what's next? You got to visualize it. In our next explainer, we're going to do exactly that. We'll connect our Prometheus server to Grafana, the go-to tool for this stuff, and turn these queries into beautiful, insightful dashboards. It's going to be a lot of fun, so stay tuned for that one.